Okay, welcome to the second video. Before we get into distributed processing, there are some terms and definitions we need to discuss. So in this presentation we'll talk about terminology, requirements, and technical skills. And we'll give each of these a little bit of detail as we progress. In terms of terms here, the machines, and we're going to implement several machines here, about 6 machines when we get going. We're going to have a machine called the header or the controller. We use the term header at CPCC, also called the examiner machine, and it's kind of like the boss machine. It's going to be the main machine where we take care of most of the control functions. We call that a header. Jumping down to the next slide here, you see this machine here, FTK3. This is the header machine, and that's the machine where the FTK full application is installed. So we're going to need a header. We're also going to need some workers. We also called helper machines, but we'll call them workers. The workers, looking in the diagram here, are the 3 machines called distributed processing workers. And these are just 3 separate machines. And notice they're all connected through a switch, through a network switch. And another device is the Oracle server or the database server. This is where the FTK database is stored. Now notice on the diagram here, the Oracle database is actually on the FTK3 machine, and we're going to talk about other options for that soon. But that functionality needs to be considered when we're talking about distributed processing, the Oracle or database functionality. As we see also here, we talk about the evidence share, also called the imaging server at CPCC. So we'll call it the imaging server. Access Data will typically call it the evidence share. You notice in the diagram that that's actually that functionality, case folder and evidence share, is on the FTK machine as well, in their sample configuration 1. We'll talk about why that's a bad idea in just a minute here. Also the case share, again, you might have remembered from the previous diagram there that the case share is also on the FTK header in that diagram. Again, probably not a great idea, but we'll talk about implementations, alternate implementations a little later. So here are the functionalities you need to be familiar with: the header functionality, worker functionality, the database functionality, the evidence or imaging share, and the case share. Those 5 concepts will be a recurring theme throughout this course. So looking at sample configuration 1 one more time, we notice here we have 4 machines. We have 3 worker machines, and 1, 2, 3 here, and a header. So we have 4 machines. There are some severe limitations to doing it this way, not the least of which this header machine is going to get greatly overloaded if the Oracle database is also on the same machine as the FTK header. If the case and evidence folders are also on that machine, there's a fairly good chance that this isn't going to work at all or not work well. You would need a really, really powerful header machine to make this work. Definitely not a recommended configuration. As we look at their second sample configuration, you see some different things have been broken out separately. You'll see that the database server now is broken out onto a separate machine, and this is just an absolute requirement. You really have to do that to make this work well. And you also notice that there's some folders down here at the bottom of the diagram, the evidence and case folders. They're broken out, kind of showing like they're on a separate server here, and that's fine. But the problem with this diagram right here is that evidence and cases seem to be looking like they're on the same machine. That's really not a good idea. The evidence server or the imaging server is going to have a tremendous I/O bandwidth requirement, and it's going to saturate his network card, and you're going to get errors if you're not very careful with this. So we strongly recommend that the evidence server and the case folder not be on the same machine. And we'll talk about that more in detail later as far as what kind of options you can have to reduce the number of machines. Because after all, if you put evidence and case on their own separate machines, you would have 1, 2, 3, 4, 5, 6, 7 machines tied up. Now we have a way of doing it where you're going to have 6 machines tied up, and we recommend, we call it the CPCC ring, we recommend in our ring the 6 machines be used for distributed processing, assuming you're going to use 3 workers. We wouldn't, if you're going to use all 3 workers plus the header, we wouldn't recommend any less than 6 machines. Terminology, as far as how distributed processing works, each evidence processing task is assigned to the image, is assigned to an engine, and they're broken up into jobs. If you process a piece of evidence, an image file, it's going to look at that task as a bunch of different jobs. Each of those jobs is also going to be broken into what's called work units. The work units will then be doled out to the header and to the other helper processor engines as required. You'll notice that if you go to the worker machines and you pull up Task Manager, you're going to see AD processor.exe and AD indexer.exe, assuming you're indexing as well. And you're going to see that those are going to stay at a pretty high level of use while that's going on. Now, all this divvying out of the work packets or work units and jobs is handled by the FTK header, and it's done over the network. So network bandwidth is really critical. You need a gigabit switch and you need gigabit NICs. Anything less just isn't going to cut it really for this type of environment. Now, as far as what kind of equipment do we recommend, and we're going to base this on the CPCC ring, and we will show some diagrams a little later on what that is. It's effectively the same as the configuration 2 slide you saw earlier, where we break out the Oracle database to a separate machine and the evidence server to a separate machine. The only difference being is we don't put evidence and case on the same machine because we think it bottlenecks the I/O. We move the evidence to a separate machine and we put the cases folder over on the Oracle machine because the I/O requirements on the Oracle machine are a good bit less. So the bottom line is we make some slight modifications to the example configuration based on pragmatic experience, and based on that ring design, and we call it a ring because the machines are arranged in kind of a circle in our lab. We would recommend, therefore, that the header machine, examiner machine, have an 8-core better processor, 12 gig of RAM, Windows 7 64-bit, an 80 gigabyte or larger, probably larger these days, solid state drive for the OS. The solid state drive really matters. It really brings the performance out in the header machine. A gigabit per second NIC, no question, that's very important. For the Oracle machine, we recommend, again, an 8-core better processor, 12 gig of RAM, 64-bit Windows 7, again, a solid state drive for the operating system, or a 160 gig SSD, or very good RAID 0 configuration with spinning drives. If you're doing spinning mass drives, we recommend at least 4 7200 RPM Velociraptors or an equivalent in a SAN or NAS type environment. Again, RAID 0 and at least 4 drives. That's going to give you what you need out of Oracle. Do not do RAID 5. If you put parity on this, it's going to slow it down tremendously, and it's not going to work well. So don't do it. RAID 0 with at least 4 drives if you're using spinning mass, or if you're conventional, or if you're using a solid state drive, you're going to be better off. So we recommend solid state wherever you can do it. For the worker machines, you don't need quite as much power. Any reasonable level machine will do, but we still recommend a 8-core processor. And even you say that's not a reasonable machine. It is when you're comparing it to the header and the Oracle server. So 8-core better machine, 8 gig of RAM, 64-bit Windows 7, a Velociraptor, a better drive, but you don't need the solid states necessarily on the worker machines. Gigabit per second NIC, however, is important. On revisiting that just a second, the workers, also the evidence server it would be good if it was around the same level of performance, and along the same lines, the case server doesn't need much at all in way of performance. So you can put cases generally on the Oracle machine with it, but the evidence share should be a standalone machine, and specifications like a worker would be fine. The only thing we do recommend on the evidence server is we do recommend a solid state drive to serve out the image because it's so much faster. And that is the only difference in the recommendations here. Other requirements, .NET's 3.5 Service Pack 1 needs to be installed on the machines to make this work. If you're using Windows Server 2008, there's some considerations about installing .NET Service Pack. You can look at the release notes from Access Data if you need to in regards to that. Just wanted you to be aware. You'll need the Access Data Processing Engine installation executable for the worker machines in addition to the normal FTK installation procedures, which we'll do later in the course here. One thing, keep in mind the full Access Data installation evidence processing engine, do not install that on the worker machines. The only thing that can exist on the worker machines in terms of FTK is the distributed processing engine. That's all you can put on it. There's some other considerations here. Access Data says that the machines that store the evidence in case folder can often become a bottleneck. Boy, did we find out the hard way about that once. That's why we have a very specific configuration recommendation at CPCC in regards to how this ring should work. The bottom line is you'll have problems if you don't use our recommendation, and if you use the recommendation, you won't have any trouble. The last thing to keep in mind is we're going to disable a lot of security features in the operating system to do distributed processing. Because of that, the switch needs to be isolated off the company network, off the school network, whatever environment you find yourself in. Distributed processing needs to take place in an isolated network. You're going to turn off firewalls, you're going to turn off the antiviruses, you're going to have permissions and shares that are very open, that don't require a lot of interaction. So it's purely a speed optimization. We are not doing it, we're not even considering security in this arrangement. So this lab has to be isolated. Whatever you're doing in terms of distributed processing, whatever environment you're using needs to be isolated. A VLAN separation could possibly work. I don't recommend it. I recommend a completely separate switch fabric isolated from anything else, at least while the distributed processing functionality is occurring. Okay, that'll do it for topic 1. Go ahead and follow the schedule for the rest of the course, and we'll see you in the lab.